In this lecture, we are going to explore some things you need to be careful about if you want to be moving temporary objects around in your C++ program. To explore this, we will use our box container class to set up a few examples. It is the same thing we have seen in the last few chapters when we talked about class templates. If this is confusing, please go back and watch that chapter, and you are going to understand everything about this box container class template that we set up in that chapter. What we will be doing is set up a simple example like this. We will have a function to create a local box object and return it. We are going to populate that with data using a simple helper function that you are going to see in a minute when we hit Visual Studio Code. This is really something to make our job easier to put data in our local box object and return it. And when we hit the main function, we are going to create an array that contains box container objects. Now, some of you must be thinking, why are you doing something this convoluted? It is just to be able to show you how we can waste data if we copy from temporary objects like we are doing here. So what we are going to do is set up a loop like we do here. This is going to loop 2 times. And at each time, we are going to create a local box object and copy that into our array. If you go on top, you're going to see that this is an array which is going to be storing box containers for int. So this is really something you need to understand. What we will get is an array, and our array is going to look something like this. And in the first slot, we will have our first index, which is going to be 0. And in the second slot here, we're going to have our first index. And the first index is going to contain a box container object, which may contain data inside. And the second slot is going to contain another box container object, which may also contain some data inside. This is the situation we have. So what we are doing here is looping around and creating a local box object. We are going to set it up, for example, like this. It is going to contain some data. By the moment this function executes, this is going to create a temporary box object. We are going to copy from it and store the data, for example, in our box container object at 0 index. We are going to put the data in, and as long as we are done putting the data in, the temporary here is going to be destroyed with the data. This is what we mean here. So at the second iteration, we are going to repeat the same thing. We are going to set up a local object. We are going to put in the data, and then we're going to copy this in the second slot for our box container array that we have here. And after we copy the data, we are going to throw away this temporary box object. And hopefully you can see that this is going to be wasteful because we are using the copy assignment operator here, which is going to copy from the temporary object. And after we do the copy, the temporary object is going to be thrown away, and we don't really want that. This is going to cause these problems because we will be using our copy assignment operator, which is what we see here. It is going to take a box container object as a parameter here. And in the body, you see that we are really not reusing the memory location we had in source. We are going to set up our own dynamic memory location, doing dynamic allocation here. And after we have this dynamically allocated, we will copy from source. That's what we do here. We are going to loop however many times we need to, and we're going to copy the data from source object and store that data in our own object here. And this is going to throw away the temporary that we are copying from, and this is really a problem. We don't want to be doing this because that's going to throw away the temporary with valuable data that we would have used and avoid setting up our own dynamic memory allocation. But we are going to see a solution to this in the next lecture. What we want to see now is that our temporary object is going to be thrown away, and that's going to be a huge waste. Now that you understand this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is moving temporaries around. We are going to grab the code from our template files and put that in place. And I am going to bring in the box container class. You don't really need to type the code here because we have designed this entire thing in a few chapters that we have done in the past. You can grab the code for this in the resource section of the lecture, and you can use it right away without having to set it up from scratch. That's going to save you a lot of time. So what I am going to do here is open this up in Visual Studio Code pretty quick. This is going to give us our box container class, which is ready made, and it has really everything we need for it to work for this lecture here. The main point of focus is going to be our copy assignment operator that we can find if we scroll down. And I think it is this little guy here on line 199. It is a copy assignment operator, and it is going to be copying from the parameter here and pasting the data in our object using the loop here. This is really nothing complicated if you made it this far in the course here. So what we are going to do in main is remove the clutter that we don't need. We are going to include our box container. Let's do that. And we will set up our two helper functions. One is going to create a box object. It is going to be called makeBox. We will give it a modifier to try and differentiate the data we put in our box container. This is what we do here. You see, what we use this modifier for is just make sure we have some different data in our box objects. We are just going to multiply with us in our populate box function here. So we are going to create a local object. We are going to put data in using the populate method, and then we're going to return the box here. So what we are going to do in the main function is set up an array of box container objects, and these box containers are going to be containing integers because of this template argument we have here. And at the moment we do this, the box container objects are going to be already created. So we will have a situation like this. We will have the same thing I showed you in the slides. We will have two slots in our array. The first slot is going to contain a box container object which contains data inside. So we may have something like this. Let's use another color. I think we can use green here. So we're going to put in the first box container object in here. It is going to be living at index 0 in our box array. We're going to set up another one which is going to live at this index here. So we put in our box container, and these guys are going to be default initialized. They are going to have a default size of 0 because they don't have anything in, and they will have a default capacity, which is whatever we set up in our box container object. This is the situation we're going to have. Now, what we want to do is to loop through this array and use the makeBox function to set up a local box object that we're going to copy the data from and initialize these arrays here. This is what we want to do. We can achieve that using a loop like this. So we are going to loop 2 times, and at each iteration, we are going to call the makeBox function to create a box object. This is going to return the box object by value. So that's going to be a temporary. Hopefully you can see where we are going here. This is going to be a temporary box object which is going to be returned. It is going to be containing data inside. And for example, this is going to be temp box. We can name that here. And we will have data in. For example, if we loop here, we may have a 1, a 2, a 3, a 4, n. And we are going to copy from this and store in our array using the copy assignment operator here. So we are going to go in the object we have in our array, and we are going to copy the data. And by the moment we are done copying the data, the temporary here is going to be thrown away, even if it contains data. And that's going to be a huge waste. So in the first iteration for this loop, we are going to set up a local object and throw it away after we copy from it. We are going to go in the second iteration. We're going to do the same thing. We are going to set up another local object, which is going to contain the data we get from our makeBox function call here. We are going to copy the data and store that in the box container object we have in the second slot in our array. And after we just make the copy, we are going to throw away this temporary here. That's going to be a huge waste. And that's what I want you to see in this program here, that we throw away these local objects. And we are going to see this through the destructors we have set up in our box container class here. Let's go up and make sure we see these destructors. We have a destructor here, and it is going to say that we just destroyed a box container object. Now, let's try and build this program and show you that. We will pass this through our favorite compiler. I am going to use GCC. And the build is going to be good. Don't mind Visual Studio Code for this error here. It is showing the error just went away. We had a line that made this file here turn red, but now it is fine, so we can move on with our code. The build is good. We can bring up a terminal window and run this program. Now, the moment we do this, we will see what is going to happen here. I think we need a bunch of separators to really see what is happening here. So let's put in the separator here, and we can grab this and also put this before we do the loop and after we create the array, and we will see what is happening here. So let's build again. The build is going to be good, so we can clear and run our program. Now we are going to see what is really happening here. Now, the first line here is going to run, and it is going to create two books container objects. And the constructors are not going to print anything. That's why we don't see anything before this separator here. But the moment we hit this loop, we are going to call the copy assignment operator, and we will say that we want to copy 20 items. We have 20 items because the make box function is going to put in 20 objects. It is going to loop for 20 times. So that's what we see here, adding stuff. And we will copy these guys. But after the copy assignment operator is called, the local object we just created, which was a temporary, is going to be destroyed. That's what we see here. So we're going to hit the second iteration. We're going to call the copy assignment operator again. We see the message here to copy 20 items, and then the temporary is going to be destroyed. Now the loop here is going to be done. We will hit this separator here and see it printed out. And then we will hit the end of the main function, and this array here is going to be destroyed, and it will be destroyed at the end here because the array itself is stored on the stack. It is not a dynamic array. This is a static array which lives on the stack. But the main message here is that we see our temporary objects destroyed even if they contain data. So what we really want is to not copy from these temporaries. We want to steal the data that they contain and avoid the job we are doing in our copy constructors, because that's really a lot. We are doing dynamic memory allocation. We are doing a lot of copies, and all these are operations that are really hard on your CPU in terms of memory used or the CPU time itself. You don't want to waste all these precious resources, and we can avoid this waste using move semantics, as we are going to see in the next lecture. Let's look at our copy constructor again, or the copy assignment operator. That's what we are looking for here. We have that on line 199 or 200 here, and you see that inside we are really doing a lot of work. If we don't have enough space, we're going to allocate new memory location. We are going to do a lot of copies, and we don't really want to do that, especially considering that we can steal from the temporary object we are copy constructing from. So what we basically want is to steal the pointer in the source object and make it ours. We are going to reset the pointer in the source object, and we are basically going to steal the data from the temporary object, and that's going to work really well. We're going to see how this works in the next lecture. So go ahead and finish up here and meet me there.